Hello all, welcome to the session. In the previous video, we discussed about Kruskal's algorithm, that is how to find a minimum spanning tree by using Kruskal's algorithm. And here today we'll discuss about finding the minimum spanning tree by applying Prim's algorithm. So how do we how do we apply Prim's algorithm to find the minimum spanning tree? So basically, you are given with a graph, okay, and you need to start with a single node in this graph. You can take any node in this graph, in the given graph, and you can start with that node, okay. From that node, what you need to do is you need to explore all the adjacent vertices of the node which is having minimum weight, and one more condition is there shouldn't be any cycle in your resultant graph. So considering all these things in mind, we are going to visit all the adjacent vertices, okay, and then we are going to construct the minimum spanning tree, right? And in this graph, okay, I have taken A as my starting node, okay. This node is my starting node. By taking this vertex, that is A, so what is the next step? I need to find the adjacents of A. Here what are all the adjacents of A? Whichever the vertex that is connected with this vertex A, okay, those are all called as adjacents. And if you take A, what are all the vertices connected with this? D and B, okay. You can see there is an edge flowing from A to D and there is an edge flowing from A to B. So these two vertices are considered as the adjacent vertices for this vertex A. Now coming to the weights of these two vertices. So this vertex, the edge that is connecting with this vertex has the weight 4 and the edge connecting with this vertex has the weight 10. Among these two, which is having the lowest weight? So the lowest weight, that is a minimum weight, is 4. Now you need to make a connection from A to D with an edge having weight 4. Okay, this is what the first step you have done. Now again, what is the second step? In second step also you need to do the same, that is considering the vertices, whatever the vertices you have chosen here, considering all these vertices, and you need to find the adjacent vertices for these two vertices. Okay, what are all the adjacents, and among all those adjacents, which is having the minimum weight, considering it shouldn't cause any cycle for my spanning tree. Okay, so here I am choosing A and D. So what are all the adjacents of A and D? So if you take A has one adjacent, that is B, which is not visited, and D has an adjacent, which is C, which is not visited. So among these two vertices, which is having the minimum weight? So this is having the minimum weight. In this case, I am going to choose D connected with C having an edge containing the weight 1, which is the minimum weight. Okay, and here there is no cycle as well. I can choose this value now, right? Now coming to the next step. In the next step, again what I should do? I should check for the adjacents of A, adjacents of D and adjacents of C. Okay, I need to consider all these vertices, adjacents. Now coming to A, the adjacent is again B with weight 2. Then coming to D, there are no adjacents left with D. So just ignore D. Now coming to C. So from C we have two adjacents. One is to B having weight 2 and other one is to E having weight 6. But if you look at these three weights, so 2 is the minimum weight, right? And if I want to connect C with B, so what I can do here, I can connect C with B with weight 2, which is having the minimum weight among all the other adjacent vertices, right? So now the next step, again you need to find the adjacents of A, D, C and B. So A to B, it is 10, but B is already visited. If we connect A and B, again will form a cycle here. You cannot consider this adjacent, and D doesn't have any adjacents to be visited. And coming to C, C has one adjacent, that is E having weight E. Then take B. B has also the same E as adjacent with weight 3. So comparatively, B and C has the minimum weight. So now what you can do is you can connect B with E having the weight 3. Okay. So if you see, you don't have any other vertices which is unvisited. So all the vertices are visited here. Okay, and then all with the minimum edges, okay, minimum weights of the edge. And if you see, there are no cycles as well. Now coming to number of edges, so totally 5 vertices in the graph. How many how many edges we should have? We should have 5 minus 1 edges, 4, right? So 1 2 3 4, yes, we got 4 edges here for the 5 vertices. So this is my spanning tree, that is minimum spanning tree. Why? Because here what is the cost? So the total cost of this tree is, 10. Okay, so this is my minimum spanning tree for this given graph. This is how you need to apply Prim's algorithm. Okay, considering any one vertex as your starting vertex, single node. Okay, start with that vertex and you need to find the adjacents of that vertex having minimum weight. Then go for connecting it. After connecting that vertex, again you need to consider both the vertices, the previous vertex as well as the new vertex you connected. Again check for the adjacents of both the vertices. Okay, among all those adjacents which is having the minimum weight. So take that one vertex. Also you should check it shouldn't form any cycle. So in that way you are going to connect with all the vertices. Okay, and then finding the minimum spanning tree.